Okay, and welcome to this next video in the mechanics series, where we'll be carrying on from the previous video looking at quantities and units and looking at forces, which will be an integral part of the course going ahead. So what is a force? Well, a force is anything that can start motion, stop motion, make objects move faster or slower, or change the direction of motion. Common forces which you will see through the course include weight, which is given by the symbol W. Description of weight is that it's a gravitational force. Okay. Normal reaction, this is probably something you've not heard before, where we investigate the perpendicular force when an object is in contact with a surface. So when any object that's on a surface will have a normal reaction force from the surface on the object. Friction. Well, friction, I'm sure that you've heard of from GCSE, is any force that opposes the direction of motion. Tension, that's the force in a string, given by symbol T. Thrust is the push or pull by a light rod. Buoyancy is the upward force on an object in a liquid. And air resistance, which is opposite to the direction of motion. So what we've got here on this page is three diagrams where we'll be looking at the forces acting on these stationary objects. Okay, so I've got this first situation here, which is a block on a flat surface, and we've got to understand what are the forces acting on this block. Now, there's one thing that I would like to add to this diagram. I personally believe I think it's better to sort of draw forces coming from the center of your diagrams, okay? So I'm just going to extend that a little bit. Anyway, so it's just a block sitting there on a flat surface. Obviously, there's a downward force, which will be the weight, okay? And then there's upward force, and that upward force is the force of the ground on the object, which we'll call the normal reaction. Okay. Then we've got a different block, a block which is on a slope or an inclined plane, as we say in A-level maths, and we've got to label these three forces. Now, if it's stationary, then again, there'll be weight here. That's always going to act downwards. There's also going to be the normal reaction force here. And remember, it's the normal reaction force because it's still perpendicular to the surface which the object is in contact with. Then you've got this final force here. Now, what we will assume is, obviously, if it's stationary, there might be some element of frictional force. Okay. Right. Final one, question one. Again, labeling these forces. You've got this person. And he's obviously got a parachute on him, he's coming down, so there's obviously the weight. Now, how you wish to interpret this, obviously he's in air, and I would think that if he's coming down, then there will be some buoyancy or air resistance. Okay, so I'd say that's the case there. Now, obviously these are all situations where we haven't got too much information, but as I said, they were just what we had. Let's look at question 2, where we had to show the forces acting on object being pulled up a rough incline. Now, the word rough in mechanics is obviously the opposite of smooth, so there is going to be friction. Now, if this object's being pulled up, I'm going to draw the force coming from the center of the object. Okay, then this will be our thrust. Okay, that's being pulled up. Obviously, there's going to be a weight. Okay, which is going to be downwards. There's also going to be a normal reaction force, which is going to be labelled as R. Okay, and obviously because it's being pulled up and there's a rough plane, then there will be friction as well. Okay, so those are all the forces labelled on that particular diagram. So that's just the beginning of thinking about forces. As you go through the course, you'll be looking at how forces interact with different surfaces and with different objects. And you've got to understand this table and when to sort of apply these symbols on these diagrams. And obviously, you can understand it once you understand what each of these forces represent. Okay, so that's the end of the video.